Okay, so we've got 3 points, A, B and C, and I've sketched them on a picture there. A, B and C. I know that ABC is a right angle, so I've put a right angle there, and I've now got to find the gradient of AB for part A. So the gradient of AB is equal to the difference in the y coordinates over the difference in the x coordinates. So putting some numbers in, I've got 2 take 1 over 7 take 1. So I've got a sixth. Let's have a look now at part B. Calculate the value of k. So k is an unknown at the moment. K is the x-coordinate of point C, but I don't know what it is. But what do I know? I know that there's perpendicularity here, so I know that the gradient of AB multiplied by the gradient of BC is minus 1. So I'll put that together. Gradient AB multiplied by the gradient of BC is minus 1. Perpendicular lines. How can I use that here? I can use that in fact by knowing what I've just worked out. I've worked out the gradient of AB, so that's a sixth. The gradient of BC I can do in a similar way, so I can do the difference in the y coordinates, so 4 take 2, over the difference in the x coordinates, so k take 7. That product must be equal to minus 1. Rearranging my equation, I've got a sixth times 2 over k minus 7 is minus 1, which means that 2 over k minus 7 equals minus 1 times 6, minus 6. Rearranging, I've got 2 divided by minus 6 equals k minus 7. So minus a third plus 7 equals k. Minus a third plus 7 is 20 over 3. And in part C says I've got to show that the length of AB can be written in the form root p, where p is an integer to be found. So I'm now going to have a look at that. So part C, the length of AB. So the AB, if we go back to that triangle situation at the beginning, AB was that line there. And I know that I can get the length of that line using Pythagoras. So the length of AB can be worked out by the square root of the difference in the x coordinates squared plus the difference in the y coordinates squared. I'm now going to put some numbers in. So I'm looking at A and looking at B. So I've got 7, take away 1 squared, that's the difference in the x coordinates, plus 2, take away 1 squared, the difference in the y coordinates. Working out those pieces, I've got 6 squared plus 1 squared, which is the root of 37. So my value for p must be 37, because I had to put it in the form root p. Okay, so we're on 7D now. We've worked out that AB is root 37 on this triangle, and we've found out that the area of ABC is equal to AB times BC divided by 2, because it's a right angle triangle. We can use base times height divided by 2. So now we're just going to put it all together. We haven't at the moment got BC, so we're going to use Pythagoras to get BC. So that would be the square root of the difference in the x coordinates. So I'm using 20 over 3 minus 7 squared, plus the difference in the y coordinates squared. Just be careful there that you do match the corresponding x's and y's. That's a pretty common mistake, to be honest. And then evaluate those pieces. So 20 over 3 take away 7 is minus a third. And 4 take 2, 2 squared. Simplify. And I got root of 37 over 9, which is equal to root 37 over 3. So that's the length of BC. And I'm going to put it all together to get the area. So we've got area equals AB, so root 37, multiplied by BC, so root 37 over 3, divided by 2. So root 37 times root 37 is 37, divided by 6. So the area of the triangle is 37 over 6. So I'm now looking at 7 part E, and I've got to get the equation of the straight line passing through B and C. And I've got to give the answer in the form ax plus by plus c is 0, with a, b and c being integers. So I've got to rearrange it at the end to make sure it's in that form. So I know that the point b is 7, 2, and the point c is 20 over 3, 4. Now b is my easier point to use because I'm going to use the equation of a straight line. Now this is incredibly useful because I can use it whenever I've got a gradient and whenever I've got a single point that the line goes through. Now I know that the gradient of BC, I knew that earlier on in the question, the gradient of BC was a perpendicular gradient to the gradient of AB. Now the gradient of AB was equal to a sixth, so the gradient of BC must be equal to minus 6. So the gradient of AB was a sixth, the gradient of BC must be minus 6, being as though those two lines are perpendicular. So I've now got all the information I want. I'm going to sub it into this equation here. So I've got y minus the y coordinate. I'm going to use b. The reason I'm going to use b is it's far easier to use b than it is c. So y minus 2 equals minus 6, x minus 7. Untidy up, expand, and rearrange. I want it in the form where everything is on one side equal to 0. So I've got 6x plus y minus 44 equals 0.